Hello everyone, we are the Group 3 and our presentation is about Chapter 7, Aviation and Information Technology. After this presentation, we would be able to gain knowledge about the information technology used in aviation, acquire ideas on how the information system supports an airline, learn how airlines operate with the help of information technology. Know the different categories of an airline. Have an idea on how airlines reservation and booking codes work. Aviation is a very complex industry. A lot of things are involved in operating an airline. Operation of an airline and airports requires precision and expertise due to its sensitivity in environment. Heavier than air machines or recalled aircrafts have been operating for over 120 years, and throughout those years, a lot of modification and evolution occurs. Stakeholders, government authorities, international organizations, employees, travelers, and residents are involved when it comes in operation of aviation. There are also a lot of personas includes in an operation of an airline such as the engineers, accountants, IT specialists, manager, meteorologists, environmental scientists, and pilots. IT supports aviation and it will be tackled in this chapter. Airlines. Airline is a company that operates and owns an aircraft responsible for transporting of things and people into different places through air. In operating an airline, it requires sophisticated system in order to have a safe and satisfying flight. Airlines can be divided into categories. The first category is the national flag carriers. This is a type of an airline that is owned by the government. Many countries continues to own stake in their national airline. The aircrafts in this kind of airline carries the name of the country where it came from. Second is the commercial airline. The commercial airline is a non-government owned and operated. This kind of airline focuses on businesses and profits through transporting cargoes and passengers to its specific destination on a scheduled time. The global distribution system has increased and developed over time due to the sharing of technological innovations with their alliance. Third is the low-cost carriers. Low-cost carriers prioritize their transportation on a low-cost fare and mostly put extra charges on their necessities like food, priority boarding, seat allocation, and baggage. It uses IT to easily automate processes with low cost but with efficiency and safe travel. Fourth is the charter airlines. Provides a leased aircrafts that can be used for package tours and usually by a sports team, cruise lines, government, and military. The IT is used to facilitate the booking and schedule of the aircraft. Airline use of information technology. Information technology supports a lot of functions when it comes to an airline. It is responsible for marketing, distribution, customer service, and operations. Reservations, bookings, ticketing, and inventory management also uses IT and computers. Information technology is the reason why modern airline exists. It ensures the efficiency and the safety operation of an airline. Altea Suite. Amadeus Altea Suite provides an information technology solution for travel industry. With the help of an open platform, allied partners can discuss their IT operation and share information. The Altea suite automates sales and reservation, inventory management, and departure control process. It also provides e-commerce to support online booking and distributions. The Amadeus Altea suite is consisted by four components. The first component is Altea reservation. Customers' profiles, distribution channels, availability, booking, pricing, and ticketing management. Second is Altea inventory, schedule, and seat capacity. Third is the Altea departure, a departure control system including check-in and boarding application, baggage management, aircraft weight and balance, and disruption management. Fourth is Altea ticketing, electronic and paper ticket issuance, ticket change function, disruption management, and electronic miscellaneous document or EMD management for ancillary sale. Airline reservation system is the most important application of information technology. It is the way that passenger can easily book their flights, also for them to know the flight schedule and the seat availability, fares, rules, and passenger information. ARS is different from GDS. ARS shows the schedule of a single airline while GDS shows multiple schedules. Most airlines uses airline reservation system, and some airlines develops their own ARS, but it is more expensive and much complex than the common ARS being used. Even though they have different features and complexity, they still serve one purpose: flight schedules and availability is an important function of the ARS. It responds to the passengers whether there is an available flight or the scheduled flights. It shows all the scheduled flights on a designated route and available seats for different classes. It is called the availability display. One of the purpose of this is that it shows other connecting flight options if the direct flight is not available. Fare codes and rules provides the seat pricing regarding which booking class it is listed. It also stores data like booking and ticketing deadlines, stopover, maximum or minimum length of stay, blackout date. Inside the cabin, seats are classified into three categories: economy, business, and first class. Fare codes and rules uses booking codes, also known as booking class or fare class. Combining the flight schedule and availability with fare codes and rules can create a best fare for every seat, which is provided by the ARS. Everything is being displayed to the ARS and GTS.
Third is passenger information. For reservations, check-ins, and other operational tasks, a passenger name record or PNR is used to store booking information for both individual travelers and groups. The PNR includes details such as the passenger's name, contact information, payment details, frequent flyer number, and a unique record locator. Last is the electronic ticketing. This is the final essential function of an airline reservation systems or ARS. It is the handling of electronic tickets, which were introduced in the mid 1990s and became mandatory for all IATA airlines in 2008. An e-ticket contains the terms and conditions of travel, along with fare and tax information. It also enables passengers to check in online and obtain a boarding pass. Decision support system. These systems are based on sophisticated models called operation research or OR models, which use what if and sensitivity analysis to investigate the impact of various factors on operations. Next is fleet management. The aircraft fleet represents a significant investment and investors expect profits. IT solutions can optimize the use of the fleet as follows. Number one is fleet acquisition, fleet assignment, and fleet maintenance. Fleet acquisition is the airlines require data to make informed decisions about the type, timing, and quantity of aircraft to acquire. IT systems provide critical information, including operation team costs and the profitability of various aircraft models. This data is also connected to scheduling and revenue management system. Second is fleet assignments. It refers to assigning aircraft to routes that should aim to maximize profits while ensuring the fleet is used efficiently. Third is the fleet maintenance. Computerized systems ensure that all aircraft undergo maintenance checks at specified intervals. They generate reports to prevent any checks or servicing from being missed. Now, let's move on to flight scheduling. Flight scheduling is a complex task requiring route planning to maximize an airline's return on investment in aircraft. Number one, a strategic goal. Strategic goal is a decisions about which markets to serve, how to respond to the competitors' schedules and pricing, and how to access necessary resources are key factors for the airlines. Second is route network. This ensures that aircraft utilization is maximized while providing convenient connections for passengers. Third is passenger demand. Scheduling flights on high demand days and times optimizes load factors and profits. Fourth is alliances. An airline must take into account not only its own schedules, but also those of its alliance partners to ensure flights are convenient for passengers. Now, let's move on to aircraft type. It is the operating characteristics like capacity, range, fuel efficiency, maintenance schedules, and turnaround times of different aircraft all influence scheduling decisions. Sixth is the human resources. This is the availability of flight crew and industrial relations legislation govern the working conditions of flight crew. Second to the last is environmental and safety regulation. Airlines and airports may comply with stringent environmental and safety requirements. Lastly is the airport restrictions, curfews, congestion, air traffic control, landing slots, and gate availability. Now, let's discuss crew scheduling system and revenue management. Crew scheduling system is a computer program called the pairing optimizer assembles flight schedules for each crew member. The process of requesting a particular schedule is called bidding. Generally, each crew member submits their bids monthly. The monthly work schedule allocated to a crew member is called a bid line, which consists of a series of crew pairings. A crew pairing is a sequence of flights or legs that start and end at the same base destination, or we called it round trips. Sometimes it is necessary to fly off duty crew members free of charge on other flights. A practice known in the industry is called deadheading. Now, let's move on to revenue management. Revenue maximization is a major focus of airline management. Airlines can maximize revenue and load factors by selling the right seats at the right price to the right person and right time. There are two components of revenue management: the price differentiation and yield management. First is the price differentiation, whereby seats on the same flights are offered at different prices with different rules and features. Second is the use of yield management, which is to determine the number of seats or booking flights or booking limits for each fare class at any given time. Airline uses revenue management systems, or also known as RMS, to calculate the booking limits on each fare class for future flights. An RMS typically includes the following capabilities in the next slide. Now, we have four revenue management. First is historical data, second is forecasting, third is modeling, and decision support. Let's discuss the four revenue management. First is historical data. It is the capturing and analyzing historical booking data to identify patterns and trends. Forecasting refers to predicting future demand based on historical data and other inputs. Modeling is recommendations and booking limits and overbooking levels that optimize expected flights, revenues using mathematical methods. Lastly is the decision support, which is an interactive decision support. It allows revenue managements to review, accept or reject booking limits and overbooking levels. Now let's proceed to flight operation systems. Flight catering systems capture special meal requests and manage the ordering, storage, preparation, and delivery of meals. A range of systems order and track the ingredients required and monitor the freshness, quality, and quantity of ingredients so that orders meet passengers' demand. Barcodes and radio frequency identification, also known as RFID, keep track of trolleys, trays, cutlery, and crockery to reduce the incidence of lost items. In our previous discussion, we covered how the travel industry has embraced to the use of the internet, social media, and mobile technologies for marketing and customer service. Now, we'll explore how airlines utilize these tools to interact directly with the passengers, offering services such as information, booking options, and loyalty programs. Now, we're going to discuss the marketing and customer relationship management. We have here direct bookings. The internet has a major impact on marketing the seats. Airline websites provide passenger with greater choice and control over seat purchase.
Loyalty programs. Full services airlines offer customers loyalty programs known as frequent flyer programs or FFPS. Passengers become members of these programs to receive benefits and enroll in the program to accumulate points or miles corresponding to the distance flown on the airlines or its alliance patterns. Members can also accumulate points through shopping and co-branded credit and debit cards. Points are redeemed for air travel upgrades, priority setting, airport access, complimentary travel products, or other good services. Airline loyalty programs rewards you for flying with them. You earn points or miles by flying using their credit cards or participating in promotions. These points can be redeemed for free flights, upgrades, baggage allowances, lodge access, and more. Programs often have status tiers like silver, gold, and platinum, offering additional benefits based on spending or activity. Choosing a program that aligns with your travel habits, and rewards you appropriately is to key maximizing its value. Customer service. Airlines were early adopters of web and email customer service tools or Dickinger and Bonfire. 2009, airlines now use mobile applications and social media to deliver relevant, time-critical procedural information to passengers, including airports, flights, information, notifications of gates opening and change, alternative flights in case of cancellation or missed flights, compensations offered, and coupons. Amadeus 2012 mobile devices also offer airlines an opportunity to sell ancillary service and upgrades even after a passenger has arrived at the airport. Airport customer service teams are there to assist passengers with a variety of needs from flight information and baggage issues to finding their way around the airport. They can help check in security delays, lost items, and any problems that arise during travel. They arrive friendly face you can turn to help and information when you need it most. Departure Control System. A departure control system or DCS automates the processing of passengers at the airport. This includes managing airport check-in and boarding, check bags, bag control, and aircraft checks. DCS typically have the following: check bag load control and aircraft checks. Departure control systems are the brains behind the airport's operations. They manage flight schedules, track aircraft movements, and ensure smooth takeoffs. This system uses real-time data to coordinate everything from gate assignments to aircraft control, keeping the airport running efficiently and safely. For the check-in support for touch points, including check-in counter staffed by airlines representatives, self-service kiosks, mobile check-in, and online check boarding pass. issues electronic and hard copy boarding pass format according to LATA standards or LATA standards. Seat allocations assigns a seat or provide the passenger with a choice of available seats displayed on a graphical seat map. Check baggage. Confirm the number of weights of checked bags automatically calculate excess baggage charge and issues bag tags according to IATA standards. Load control. Automate the task of calculating load distribution and balance by using load factors, seat allocations, and baggage weight. Passenger identification. Scan passport to verify the identity of passengers. Deny boarding. Deny boarding if details are missing from the PNR, if the flight is overbooked, or if there is a perceived risk. No shore, shows and standby passengers. Allocate empty seats to standby passengers at the last minute. No show passengers have reservation but do not turn up for boarding while standby passengers arrive at the airport without a reservation when they miss flight or wish take an earlier flight. Interline connections. Passenger traveling in interline tickets or connecting flights should be able to check baggage through to final destination. In case of delays, the DCS identifies alternative flights and connections, and the transfer, rebooking, and rechecking of passengers. Territory parability. The DCS must interface with the ARS to identify, capture, and update PNR reservation. The DCS will change the status of passengers to check in board, loan, or other status. The DCS may also be connected to immigration control for visa immigration and passenger while watch list. The DCS used by most North American Airlines Incorporated into ARS, but outside North America they often provide by third-party vendors such as Amadeus, Travelport, and SITA. These vendors have developed need next generation DCS as a part of the re-engineering of airlines passenger service system or PSS. They use integrated database open architecture to allow reservation, check-in and other service and maintain consistent view passengers information to to see an example of an integrated system, watch the following. Gate controls. Flight arrivals in airport must be coordinated with airport facilities. Each flight needs a gate assignment upon arrival and must depart the gate on time to avoid causing delays to other flights. Arriving aircraft need the skyways to disembark the passenger into the terminal access for the vehicles to service the aircraft preparation for another flight. Example of such service are food service, cleaning, fueling, and maintenance. Flight dispatcher. An airline dispatcher is responsible for planning and monitoring the progress of the aircraft journey. The dispatcher is like a big brother or sister, the pilot and air traffic control to ensure a safe journey. The pilot and dispatcher jointly share legal responsibility for flight safety. A dispatcher prepares the flight plan for each journey had has the authority to delay, divert, or cancel flights at any time. The dispatcher also calculates the weights of the aircrafts, the amount of fuel required, the distance, maintenance, limitation, weather conditions, and other factors affecting flight safety. In-flight technologies. A range of in-flight technologies are used on board to service passenger needs and to ensure safety. These IT applications can be divided into passenger technologies and crew support system. Flight dispatchers are unsung heroes air travel. They work behind the scenes, coordinating all aspects of flight from weather monitoring and fuel calculations to route planning and communication with pilots. They ensure flights operate safely and efficiently, playing with a vital role every day takeoff and landing. Passenger technologies. The passenger seats is a hub of computer technology. Seat backs now include touch screen and flight entertainment or IFE system and communication tools such as phones, Wi-Fi, and the ability to communicate to flight attendants and to passengers. Video screens in the seat back allows passenger to view live satellite television or video on demand or VOD. Listen to music, shop for duty-free items or order foods, send and receive email, play video games and even gamble. A visual geography information system or GIS. Crew support system. A flight will usually be supported to two crews, the flight deck crew including the captain, first officer and flight engineer, and the cabin crew consisting of the customer service manager of purpose, and flight attendants. Both crew use different IT. A crew support system is a vital tool for airlines providing critical information and resources to flight crews. It helps them manage their schedules, access flight plans, communicate with ground staff, and even receive training updates. This system ensures crew are well prepared and equipped to handle any situation during flights. An example is specific future. Airports. Modern airports are complex ecosystem of businesses, services, and facilities. The scale and size of some airports makes them to similar small cities. The modern airport terminal houses a range of features such as check-in facilities, security, customs and immigration, ground handling, baggage and cargo handling, and concessions such as food, beverage, and retail outlets. Terminals are either domestic or international, with international airports requiring more security and services. The terminal can also be divided into landside areas of security clearance and airside areas beyond the security clearance, which are managed differently. Other areas of the airport includes air traffic control and runways, and aprons used to take off, landing, taxiing, and parking aircraft managed pri- private, priva- privati- private.
Passenger processing. Airlines use a variety of departure and gate control systems to support passengers as they journey through an airport from check-in to boarding. Airports work together with airlines and IT to provide these systems. Pre-arrival. Airports are also using geofencing, which track passengers using an airport or airline app installed on their mobile device. Virtual geofences are built around an airport at different proximities and triggers are attached to each fence as shown in Fig. Next, check-in. The check-in process is increasingly managed before passengers arrive at the airport and there has been a major shift away from check-in counters to self-service kiosks. These kiosks are linked to an airline DCs, and passengers can check in by entering their name and destination, record locator, frequent flyer membership card, or passport. Security and immigration. The protection of passengers, staff, and aircraft is one of the most important considerations for an airport. The role of airport security system is to identify and manage external and internal threats. Internal threats occur when employees inside a terminal pose a risk to passengers or their belongings. Security systems monitor baggage and handling facilities to prevent baggage or cargo theft and tampering. External threats arise from passengers and other unauthorized individuals.
confirming the identity of travelers. This is done through visual and electronic check of passports and boarding passes or biometric systems. Next, X-ray baggage screening. Carry-on luggage and check bags are screened using X-ray machine monitored by security personnel. Next, body screening. Passengers are usually screened by walking through a metal detector. Pre-boarding. Passengers enter the airside of the terminal after they have cleared security and immigration. When travelers are unfamiliar airports, they have critical need for information about airport activities and facilities.
Boarding. Busy airports often have noisy boarding processes, but new innovations like IATA barcoded boarding passes or BCBP and Apple Passbook, Bluetooth technologies, and biometrics can streamline the process. These technologies allow passengers to board through electronic screening points, reducing codes at boarding gates and allowing aircraft to load more quickly, ultimately improving the overall airport experience. Stopover. Transit airports often require passengers to stop over for flights, and they often utilize IT facilities like free Wi-Fi, airport apps, and FIDS. These facilities cater to passengers' needs for rest, relaxation, and communication. Airports provide computer terminals for internet access, digital information for showers and quiet zones, and free sleep pods with special lighting and audio. Mobile apps can also assist passengers who miss connecting flights by booking alternative flights. Arrival: The departure and arrival experiences of airlines and airports are crucial for visitors, and free Wi-Fi is essential for arrivals. NFC and Bluetooth technologies can send visitor information to mobile devices. Immigration documents are processed, time-consuming in international gateway airports, and biometric systems screen passengers. Governments have computerized immigration control, digitizing passports and visas, and determining risk profiles based on passengers' data. I- IT applications track baggage handling, and mobile apps can book taxis and ground transport. Technology companies like Sita are developing business intelligence tools to provide real-time performance data, and location-aware technologies enable airport stakeholders to anticipate and plan for peak events and disruptions. Baggage and cargo handling. Airlines and airports are investing in baggage handling systems to prevent lost or mishandled baggage, which cost the industry an estimated US$ 2.1 billion a year. PHS use optical barcoded baggage tags, which are scanned to check-in and connected to reservation and passenger processing systems. This information is then connected to central baggage tracking systems like SITA's BagTrack. Optical scanning technology reads bag tags as they move along conveyor belts, ensuring each bag ends up at the correct destination. Recent developments use ambient intelligence such as RFID bag tags and chips embedded in luggage to increase passenger and baggage processing efficiency. Air traffic. Air traffic control is a vital component in aviation safety and efficiency, tracking every flight from takeoff to landing. It achieves this through efficient flow of air traffic using four interconnected IT systems. Communications systems. Pilots and dispatchers utilize various communication systems, including VHF for short distances, HF shortwave or satellite-based for longer distances, and iCars for data transmission, with recent ATN advancement improving communication capabilities. Navigation system. Pilots and controllers are used a number of different navigation systems during takeoff, cruising, and landing. Signals generate a visual display of the aircraft's position on a monitor. Surveillance system. Controllers use surveillance systems to monitor the flow and positioning of air traffic. Many rely on radar to display the position of each aircraft on a monitor. Flight and weather information systems. Decision support systems manage airport traffic. Flight data processing processes distribute flight plans, and weather information systems provide weather observations, forecasts, and alerts. Environmental management systems. Airports use IT to manage the environmental impacts of their operations by using environmental management systems. Aviation impacts the environment at the local, regional, and global levels. Examples of these impacts include water quality. The quality of waterways is affected by runoff from terminal buildings, runways, and aprons. De-icing operations, fuel leaks and spills, and other solid and liquid wastes. Noise pollution. Noise from aircraft causes sleep disturbance and impacts on property values. Air pollution. Pollution from aircraft adversely affects air quality by increasing greenhouse gases such as CO2 into the atmosphere. Wildlife. Aircraft movements impact wildlife feeding, breeding, and migration patterns and are a threat to bird life around airports. To manage these impacts, governments impose strict environmental regulations on airports. Technologies manage or reduce the impact of aviation operations on the environment, including environmental monitoring. Computers and specialized equipment are used to analyze, record, and report air and water samples collected by airports as part of the regulatory requirements. Energy use. IT systems monitor energy use and shut down non-essential services when not in use. Noise reduction. Computers are used to model aircraft and engine designs before prototypes are produced. New technologies supporting a continuous descent approach also alleviate some noise. Carbon emission. Computer design in engine and aircraft enhances fuel efficiency, enabling carbon offset purchases and monitoring greenhouse gas emissions impact on climate change. Water quality. Computerized spraying systems use aircraft de-icing fluids to reduce water wastage, while ice detection systems employ magnetostrictive, electromagnetic, and ultrasonic technologies for ice detection. Summary: the aviation industry has effectively utilized IT to thrive in a competitive and volatile market. The industry has developed numerous systems for massive information processing and data communications, making it a prime example of successful information system application in operations, marketing, and management. As demand for airlines and airports increases, airlines must invest in a new technologies to enhance efficiency, comfort, and safety. This chapter suggests how IT can enhance the passenger experience and aviation operations through convergence of various technologies and innovation.